The derivative of standard function. The first column represents the original function and the second column represents the function after differentiation. Number 1. Differentiate constant equal 0. Number 2. Differentiate x power n equal nx power n minus 1. Number 3. Differentiate sin x equal cos x. Number 4. Differentiate cos x equal negative sin x. Number 5. Differentiate tan x equal secant square x. Number 6. Differentiate secant x equal secant x tan x. Number 7. Differentiate ln x equal 1 over x. And the last one, number 8. Differentiate exponent x equal exponent x. The derivative of composite function by using the chain rule. To differentiate composite function or fungsi gabungan, firstly, put numbers according to the sequence on which function that we will differentiate first. Normally, we will start from the most outside function and coming to the inside. So this is an example of a composite function. It is a combination of x cubed plus x minus 1 and power 5. So first, we will differentiate power 5 because x cubed plus x minus 1 is inside the power 5. Number 2, we will differentiate the equation inside the bracket. Differentiate power 5, 5, power 4. When we differentiate number 1, number 2 should stay the same. And then multiply. Differentiate number 2. Differentiate x cubed 3x squared plus differentiate x 1. Differentiate negative 1 is 0. As for the final answer, combine these two solutions. And this is the final answer. Moving on to the next example. Here we have another composite function. Y equal ln 5x squared minus 2x. So again, this is a combination of two functions. Number 1, ln, and number 2, 5x squared minus 2x. We put ln as number 1 and the bracket as number 2 because the equation inside the bracket is inside the function ln. Now, let's differentiate ln. As we already know, the derivative of ln x is equal to 1 over x. So when we differentiate ln 5x squared minus 2x, it's equal to 1 over 5x squared minus 2x because the second function should stay the same when we differentiate the first function. Then multiply, differentiate the second function. So differentiate 5x squared, 10x, minus differentiate 2x, we get 2. As for the final solution, combine these two answers. Y equal ln sine 3x, which is the combination of three different functions. Function 3x is inside sine, and function sine 3x is inside ln. We will put ln as number 1, sine number 2, and 3x as number 3. Differentiate ln x is 1 over x. So when we differentiate ln sine 3x, the answer is 1 over sine 3x. Remember, when we differentiate ln, sine and 3x should stay the same. Multiply by differentiate the second function. Now, we will differentiate sine 3x. Remember, differentiate sine x equal to cos x. So when we differentiate sine 3x, it will equal to cos 3x. And lastly, we will differentiate 3x. The answer is 3. As for the final solution, we will combine all three answers. We can further simplify the solution because we know that cos 3x over sin 3x is cot 3x. One more example. Here we have another composite function. Y equals sine square root 3x squared plus 2x minus 5. Let's change square root into power 1 over 2. Number 1, sine. Number 2, power 1 over 2. And number 3 is the bracket. Differentiate sin x is cos x. Now, we differentiate sine square root of 3x squared plus 2x minus 5, which equal to and then multiply with the second differentiation, which we will differentiate the power of 1 over 2. And lastly, we will differentiate the function inside the bracket. And then, do not forget to combine all three solutions as our final answer. More example on the derivative of composite function. Given y equal x square minus 3x cubed power 14. We want to find dy over dx. So number 1, we will differentiate power 14 and multiply by differentiate bracket. Differentiate power 14. Bring 14 to the front and then 14 minus 1. So we get 14 multiply x square minus 3x cubed power 13. Multiply by differentiate the equation inside bracket. Differentiate x square, we get 2x minus differentiate 3x cubed 9x square. As for the final answer, combine. Next example, we have y equal secant 5x and we want to find dy over dx. Number 1, differentiate secant. Differentiate secant x equal secant x tan x. Here, we differentiate secant 5x. So, it equal to secant 5x tan 5x. Number 2, differentiate 5x, which equal to 5. Final answer, 5 secant 5x tan 5x. Given y equal square root sine exponent x square, we want to find dy over dx. First, we can change square root into power 1 over 2. To differentiate this function, we need to differentiate 4 times. Number 1, differentiate power 1 over 2. And then differentiate sine. Then differentiate exponent. And lastly, differentiate x square. Differentiate power 1 over 2, we get 1 over 2 sine exponent x square power negative 1 over 2. Multiply, differentiate sine, we get cos exponent x square. Number 3, differentiate exponent x square, we get exponent x square. And lastly, differentiate x square, we get 2x. As for the final answer, combine the solution. We can simplify 1 over 2 and 2x. Power negative 1 over 2 is square root but at the denominator. So, we get x exponent x square cos exponent x square over square root sine exponent x square. Next example, given y equal ln tan exponent to x. Can you guess how many times do we need to differentiate in order to find dy over dx? The answer is 4 times. Number 1, differentiate ln. Number 2, differentiate tan. Number 3, differentiate exponent. And number 4, differentiate 2x. Differentiate ln x is 1 over x. So when we differentiate ln tan exponent to x, we get 1 over tan exponent to x. Differentiate tan x is secant x square. So when we differentiate tan exponent to x, we get secant square exponent to x. Next, differentiate exponent, which will still give us the same equation, exponent to x. And lastly, differentiate to x, we get 2. As for the final answer, combine the whole solution.